The next sorting algorithm that we will be implementing is merge sorting algorithm. So as part of the previous sorting algorithms, we have discussed bubble sorting algorithm, selection sorting algorithm, and insertion sorting algorithm, right? All those sorting algorithms were basically in place sorting algorithms. That basically means that whatever the input array that we get the values in that array itself, basically we were trying to compare and basically trying to swap the values according to the respective algorithm that we have for each and every sorting algorithm. In the end, by following the same process, in the end, in the same array we are getting the sorted array. But when we talk about the merge sorting algorithm, it is not a in-place sorting algorithm. The main principle behind merge sorting algorithm is that it is a divide and conquer based sorting algorithm. What do I mean by that is, whatever the input array that we get, right, why don't we divide the array into two sections, I mean two parts, and why don't we sort those parts, and in the end why don't we merge them into a single array, such that in the end basically we will have the sorted array finally. So while merging the two sorted arrays that we get, we will basically be using the previously implemented merge to sorted arrays functionality. Okay, so the main idea behind merge sorting algorithm is dividing the array into two halves, such that first we will try to sort each and every half, later we can try to merge those arrays such that it will basically give us the sorted array in the end. But the thing is, how many times we will basically divide the array into two equal parts? That is the big question that we have in the merge sorting algorithm. Basically, merge sorting algorithm says that we need to divide the array into two halves till we reach a point where we have only one value in the divided part. Because when we have only one value in the divided array, then it itself is sorted, right? For example, let's just assume the array that we have got is having only one value. That means the array has only 10 in it. That means it itself is sorted, right? So as part of the merge sorting algorithm, we will try to divide the arrays as long as we reach a point where we have only one value in it. After that, since the array which has only one value, it itself is sorted, right? Then we will try to merge them such that they will basically yield the larger sorted arrays. By following the same process, in the end we basically get the sorted array in the end. For example, let's just assume that the array of values that we have got are something what you see on the screen, and our aim is to sort these values using the merge sorting algorithm in the ascending order. Okay, so by following the definition of merge sorting algorithm, we will try to divide the array into two halves till we reach a point where we have only one value, right? So here how many values we have? 1 0 1 2 3 4 5 6. That basically means that we totally have 7 values. So we need to try to divide it into two halves. That means 7 by 2 is nothing but 3.5. That basically means we will floor it, so we will get till index 3. That means from index 0 to 2 we will divide it into one part, and from index 3 to 6 we will divide it into one part. So one part will have 1 4 minus 5, and another part will have 3 7 minus 2 and minus 10. So our aim is to sort these two arrays such that in the end we can merge them so that we will get the sorted array finally. But the thing is, whatever the divided arrays that we have done, they don't have only one value. So that basically means that we need to divide them into further subparts. For that, here the array that we have here basically has three values. So to divide it into half, 3 by 2 is nothing but 1.5, which is nothing but 1 after flooring it. So till index 1 we will divide it into one part, and from index 1 till the end we will divide it into second half. So first half of the array will have only one value, which is 1, and second half of the array will have 4 and minus 5. Similarly, here on this array we have 4 values. So 4 by 2 is nothing but 2. So till from index 0 till 2 we will divide it into one part, and from index 2 to end we will divide it into another part. So the array will have 3 7 and minus 2 comma minus 10. Okay, now here if you see this array, it has only one value. That means it itself is sorted. So we have to worry about this array right now. Right now on this array we basically have two values, right? 2 by 2 is nothing but 1. That means till index we will divide it into one half, and from index till the end we will divide it into another part. So we basically have 4 and minus 5. Similarly, after dividing this array into two halves, we will basically get 3 and 7. So this array also minus 2 and minus 10. So right now, whatever the sub arrays that you are seeing here, right, they basically have only one value left in it. So since the array has only one value, it itself is sorted, right? So we will simply return that here. That means array A1 that we have, which is sorted, has only one in it. Okay, we have returned the sorted array in which we have only one value. Right now, similarly, let's continue the same process for this array. Here, if we return this array, array 1 basically has only one value with 4. And since it also has only one value, it itself is sorted, so we will return that. As a result, the sorted second result array has minus 5. Since these two arrays are sorted, what we can do, we can merge them. Once we merge them using the previously implemented merge to sorted arrays function, the resulting array that we get will be minus 5 and 4. So this resulting array we will return it. Okay, now here the A2 will be minus 5 and 4 and A1 is 1. So we will merge these two. As a result, the resulting array that we will get will be minus 5, 1, 4. Okay, do you see, in each and every step, once we get the two sorted arrays, we are basically merging them so that we basically get the larger sorted array. By repeating the same process above, whatever the divided arrays, by repeating the same process, we are basically getting the larger sorted array. In the end, basically we will get the entire array sorted. Here we will return this sorted array to the main function. This is nothing but A1. Now here, since it is already sorted, we will return A1, which has only one value, that is 3. And here this also has only one value, so we will return 7, which also has a one value. After merging these two, the resulting array is 3 and 7. This we will return back to the parent, and 3 and 7 is one sorted function. And here after merging these two, we will basically get minus 10 and minus 2. This we will return here, and minus 10 and minus 2. Now once we merge these two, right, the resulting array will be minus 10, minus 2, 3 and 7. Now we have A1 and we also have A2. Once we merge these two, the resulting array will be minus 10, minus 5, minus 2, 1, 3, 4 and 7. Okay, so that is the step-by-step process that we follow for implementing the merge sorting algorithm. Just remember that the entire idea behind merge sorting algorithm is divide and conquer. So we basically divide the array into two halves, such that first we will try to sort these individual halves, so that in the end, if we merge them, we will basically get the sorted array. But we need to divide each and every half till we have a sub array in which we have only one value, because when we have only one value in the array, it itself is sorted, so we can merge them to get the array in which we have two sorted values. As a result, as we repeat the same process, we will basically get the sorted array in the end. Okay, so that is the step-by-step process. Now that we have seen the merge sorting algorithm and how it uses the divide and conquer based step-by-step process, we have dry run on a simple array, right? Let's just try to write the pseudocode of it, and after that let's just try to implement it. Since it is a divide and conquer based implementation, right, recursive way is the best way to implement it. So I'm going to write the merge sorting algorithm in a recursive fashion. So for implementing the merge sorting algorithm, what I will do is I will write one function called merge sorting, and it will basically take the array that needs to be sorted either in the ascending order or in the descending order. So as part of the first step, what I will do is we will need to divide the array till we reach a point where we have only one value left in the array that we get. That's the reason why, as part of the, since I mentioned that I'll be using the recursive approach, I need to call the same merge sorting function till I reach a point whatever the array that I am getting in the function argument, still it has only one value. That's the reason why once we have array with one value, we no longer need to divide it, because the array which has only one value, it itself is sorted. So we need to return that array itself. That's the reason why I am going to use it as a base case for the recursive calls to stop. So if at all, if the length of the array that I have got, if it is equal to 1, that means that I have divided the entire array that I have got till to a point I have only one value. Since I have only one value, I will simply return the array itself. Okay, if this is not the case, then we have to divide the array into two halves, right? Two halves is nothing but length of the array divided by 2. That's the reason why we will create one variable called mid. This will be length of array divided by 2. Now what we need to do, we need to divide the array into two halves, from 0th index till this middle index, and from middle index till the last index we have in the array. For dividing that array, what I will do is I will call the same merge sorting function. So what I will do is I will call the same merge sorting function. In this, basically we will have the values from 0th index till middle index minus 1. Okay, and in the end, basically if we reach a point where we will get array we have only one value, in the end we will merge the sorted array, right? So this part is nothing but left part of the array. So I will simply store this result that I am getting as part of the previous merge sorting calls that we do. I am going to store it in one variable left. Similarly, I need to divide the array on the right part of the array, that means from middle index till the last index, so that I can sort those values as well, right? So I will store that result that I get into right variable. For dividing and sorting the right part of the array, I will call the same merge sorting array. In this, basically we will have the values from middle index till the last index, that means length of the array minus 1. Okay, once we get these two sorted result, what we need to do, we need to merge them, right? So for that we have already implemented merge to sorted arrays functionality, right? So immediately what I will do is I will create one variable called sorted array, and I will assign the result of merge to sorted function call that we have implemented. So I'm going to represent that here as merge to sorted arrays. So to this we need to pass two sorted arrays, right, which is nothing but left and right. In the end, I will simply return the sorted array itself, so that this sorted array will be used as part of the next merging. Okay, so that is the pseudocode of implementing the merge sorting algorithm using recursion. So remember that in each and every step we are trying to divide the array into two halves and trying to sort them so that we can merge those two halves to get the sorted array in the end. And the division needs to happen till we have only one value in the array. That's why as part of the base case I am putting a check where the divided array has only one value or not. If so, I am simply going to return it. Okay, so that is the pseudocode of merge sorting algorithm using the recursive approach.